The sustainability of intensive cattle farming in Europe is being questioned due to trade-offs regarding the environment and animal welfare, as well as the sources of cattle feed. Within the EU-funded IRANET project SUSCAT, a pan-European consortium is looking for ways to alleviate these negative impacts while still providing high-quality products with better environmental performance. Pastures may be key to solving this puzzle. Many consumers place high value on milk from grazing cows due to its high nutritional quality and potential for animal welfare in the environment. However, all dairy cows emit methane, a potent greenhouse gas, as part of their digestion. Until now, the general belief has been that methane emissions were higher from grazing cattle as compared to those raised in indoor systems, because grazing represents a less efficient source of feed. The reality is more complex, however. Different feed sources vary in the amount of methane they produce, and several herbs have been hypothesized to reduce methane emissions. At the same time, those same herbs could provide additional ecosystem services, such as enhancing carbon sequestration rates and enhancing biodiversity. At CAU Kiel, researchers tested whether pastures planted with certain herbs could possibly meet the goal of nutritious, sustainably produced milk with lower methane emissions. What did the trials look like exactly? 3 different pasture systems, each with a different level of sward complexity, were established. They ranged from a simple mixture of white clover and perennial ryegrass, all the way up to 8 different species, including 3 legumes and 4 species of herbs. The dairy herd was comprised of 90 spring-calving Jersey cows that grazed full-time during most of the experiment. They received 2 kilograms of concentrate per cow per day, provided at milking. The animals rotated twice per day. The pastures had maximum pre-grazing heights of 10 centimeters. In total, each pasture was grazed 10 to 11 times per year. What were the results? Clearly encouraging. We found that in well-managed pasture systems, both milk yield and methane emissions were either comparable or lower in comparison to barn systems. In addition, we identified several herbs that show potential to substantially reduce the cow's methane emissions. Under intensive grazing, persistence of these herbs was an issue, however. In summary, this study has clearly shown that pasture systems can result in very low methane emissions. This can be achieved by either increasing digestibility and thus maximizing feed efficiency, or in more extensive systems with lower feed efficiency by including herbs that reduce methane emissions. More research is needed to determine which botanical composition will ensure that those benefits last over time.